I'm sorry. I'm a little bit pissed off, okay? I'm not pissed off at those, let's say, 12 students. There's 12 students in here that look like they did the homework and took the test and didn't have a single problem. So let's see, we got 16 in here. So 12 of y'all didn't have a problem. But the others, the dog ate my homework, it rained, and water fell in the keyboard of my computer, and I didn't know, and I thought it was due tomorrow at noon. And when is all my assignments due? From the first day of class. When are all my assignments due? What time do all my assignments get turned in? What time?
11:50.
Not date. What time?
11:59
p.m. and that's midnight, right? Have I deviated from that from the last 6 to 8 weeks? Have I deviated from midnight? No. So I'm sorry. Cow horns will hook. If you don't do what you're supposed to, whether it's in academia or whether it's in the real world, you're going to get hooked. Okay, I'm done. I told y'all yesterday, I warned you. Now, on the lighter side of things, I want everybody to listen to this because somebody's going to say I didn't tell you. Mr. Piella, Piella, who else has had me before? Somebody speak up. Who else has had me before?
I had you in the fall.
Okay. Do I give everybody a second chance? Yes or no?
Yes.
Do you have to look for it?
Yes.
Yeah.
Okay, so what I would suggest, those 9 or 10 students that didn't believe cow horns will hook, you need to focus on the unit test, which is due tonight, and then you need to look for the chance to redeem yourself before the end of the semester. But you'll have to look for it. I'll tell you this, it's usually the last couple of weeks of the semester. Does everybody understand what I just said?
Yes, sir.
I will give you a chance to redeem yourself with any missing assignments toward the end of the semester. But right now, you need to focus on the test because that's 80% of your test. I mean, your grade. And that's all I'm going to discuss of that subject. I'm done. All right. Now, today, I just sent out the integration. Let me show you what we're going to be doing the next couple of weeks. Because all I care about is this right here. And some of my marker has bled through my, ooh, that looks awful. Well, it's marker, it's not food or drink, it's marker. Okay, y'all see my syllabus, right?
Yep.
Now, this is all I care about right here. I care about the integral from integration down to the substitution rule. So I'm going to highlight those for you. I'm telling you what's going to be on the next couple of tests. Okay, definite integral all the way down to the substitution rule. And then we might get into this for sure, and then maybe these two. That's what I'm going to focus on for the next couple of weeks. And if we get through this, then we'll jump back and get started on the unit that we skipped. So I need you to make sure that you make a note of this, especially those people that forget and don't know, I need you to take a highlighter and you need to highlight this. I'm talking to those 8 or 9 people that started their Chapter 3 homework yesterday. 11 sections. Yeah, I'm going to keep hitting. Yeah, I'm going to keep hitting. All right, I need you to write that down because that's what we're going to go over the next couple of weeks. And I don't care if I don't know. I might put this on this test, and we may make this one test. Okay? Unless I change my mind. Any questions so far?
No.
Let's see how many we got. We got 19 in the class, and we got 18 on video. Now we got 19 on video. See, I have to do that every morning, or y'all won't turn on your videos.
It's me. My camera on my computer is
Say
always
again?
like my camera on my computer always like glitches in and out. So sorry about that.
That's all right. I'm not fussing that much. I am fussing about the 9 people that tried to start doing homework yesterday. I am fussing about that, but I'll try to curb my temper on that. All right, so here we go. We'll show y'all something. Read over that right quick. Well, something happened to me. There we go. I like Foxtrot. I think it's a funny comic strip. Word problems. Nothing but word problems. Thank you. Farmer Bob's vegetable garden is 20 feet wide by 30 feet long. Calculate its area in square footage. 20 by 30. Put it on a graph. F of x is equal to 20. Y is equal to 20. Area is equal to the integration or the antiderivative of f of x from 0 to 30. And that's equal to 20 dx from 0 to 30. So that's 20x evaluated at 30 and 0, which is 600 square feet. So somebody that has good reading retention, tell me what integration does as far as math from this basic comic strip.
Finds the area of things.
It finds the area. You need to write that down. We're going to write that in red in big bold letters. The reason we are studying area, the reason we are studying the antiderivative or integration is to find the area. Okay? Now, well, Hubert, back in algebra, all we did was take the length times the width. Or the base times the height. Or with a triangle, 1/2 base times height. Yeah, that was with algebra. We're not in algebra anymore. What did we combine with algebra to do derivatives?
Calculus.
Calculus.
The limit theory or calculus, and we got calculus when we did the limit theory. So we're going to apply the limit theory to area, and we're going to get basically, and that is when talking about dx getting smaller and smaller, like the width of a what?
Hair.
Got to think out of the box, the width of a hair. And you put these two together, algebra with area plus the limit theory, and now you've got integration. Okay, what the heck are you talking about, Hubert? Well, let's take something very simple. Let's take a rectangle. I got to get another because this one's ready for the trash can. Let's draw a rectangle on a graph just like the guy on Foxtrot did. And let's say that this, just say this is 20 or 10 and this is 5. Okay? Then I can break up this big rectangle into 10 smaller rectangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one is worth 1 dx is 1. So each one of these units is 5 times 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 5 square units. This is 5 square units. This is 5 square units. This is 5 square units, and so on. So the area is equal to 50 square units. Or you could just do 10 times 5. But I want you to focus on these little rectangles, because those little rectangles are what we're going to be talking about in chapter 5. Those rectangles have a width of dx. Okay? Each one of those rectangles have a width of dx. And this is going to shrink, and it's going to get smaller and smaller to each one of these boxes are going to be the width of a hair. Why? Because the smaller these boxes are under a what? Under a curve, the what? The smaller these boxes are under a curve, the what? The more accurate. Okay, just bear with me. Okay, if we change this rectangle to a curve, then we have to extend these boxes, and that height of that curve is different at different places. And if we use a big box, that error up here, and we'll take that pink highlighter, and we'll call this error. Those red triangles right there, or rectangles, or whatever you want to call them, what does that do to our answer? It makes our answer wrong. So what you do is you use the limit theory and you break those in half. And what happens when you break those rectangles in half? What does that do to the area in pink? It makes it what? It makes that area in pink get smaller. And once you get the width of a hair, the area up here is just about null and void. So your goal in calculus is to find the area under the curve as accurate as possible. That is your goal in calculus in chapter 5. To find the area under the curve as accurate as possible. Now, what does the limit theory do in calculus? The limit theory and why ain't it sweeping? There we go. There's what your limit theory does. Your limit theory, and look at the hairs, look at the little boxes. You see those little boxes? Just think of those being the width of a hair. And you're finding the area under each one of those. And you can go from left to right, or you can go from right to left. It doesn't matter. Now, everybody look at what this thing is doing, because that is what you're going to be doing in chapter 5. So, of course, that area is 2 by 3, which is 6 square units. But that is also a rectangle. And a rectangle y'all can do in your head. But not everything is going to be a rectangle. Sometimes you're going to have triangles. Sometimes you're going to have circles. And sometimes you're going to have whatever's left. Okay? And where does this ultimately lead to? This ultimately leads to area between two curves. And where you're finding the area between two curves. Now, this has all kinds of applications, whether you're a mechanical engineer, a civil engineer, an architect, land surveyor, whatever you want to call it. Okay, not only in ceramics, you're finding the area of a part, the area of a bowl, the area of whatever. Okay, this is all kinds of applications, not even getting into 3-dimensional, but just 2-dimensional. This is your goal of chapter 5. Now, if you start it right and start with the basics, this is not a problem. This is a very simple integration problem. But you got to start off with the basics, and you got to know what's what. Okay? So does everybody understand what we're heading toward? You're heading toward the area under a curve. Now, Riemann, what is Riemann? I'm going to show you what Riemann is. Do y'all remember when we were doing the difference quotient and I was telling you to take the algebra and put the limit with it? Y'all remember that? To do the derivative? Riemann is the same thing with the area, but I'm not going to cover it, okay? I will show it to you if I've got one in here. I don't know if Riemann is in here. There's Riemann. Now, what Riemann does is he starts off with big rectangles. And there's your differences. You either got differences on the right or you've got differences on the left, either one. The overflow, see that overflow right there, that overflow right there, got overflow right here, and underflow here, underflow, underflow, or if you go to the right, sorry, there we go. You got different ones there. And I thought he was going to shade it. Okay, it's not going to shade it. But there's Riemann. And Riemann says that what you do is you find the midpoint of these two, and you take that and you multiply that height, and you multiply it by the base. So if this base was 2, and this height right here was 5, then the area of that rectangle is 10. And the midpoint here, 2 times 8. and 2 times 6 and 2 times 9 or 2 times 7 and 2 times whatever. Okay, that's rhyming. I was going to try to find a better. No. Hold on a second. Well, it's not going to show you. I was wanting it to show you. There we go. And this is what happens when you make the rectangle smaller. And you see it can keep going. And what's happening to the errors?
They get smaller.
They're getting smaller and smaller. Look. And if you think outside the box, when those boxes get, now watch it. When those boxes get as thin as the width of a hair, your error up here is just about nothing. So that's why it's very important that you understand what you're doing. Now, let me write this down again for you. And again, I'm not going to spend a lot of time with rhyming because y'all see, hopefully, out of the first unit, you see that, well, let me write it down like this. For derivatives, for derivation, I showed you that if you took the algebra with the difference quotient and you added it to the limit theory as h approaches 0, you had basically calculus, and you were finding the derivative. Riemann does the same thing, except with integration. Riemann, I don't even know how to spell his name. I know that's awful. E, it's always an E, M-A-N-N, yeah. Riemann takes your area of a rectangle and combines it with the limit theory where x, delta x, which is the width of the rectangle, is approaching 0. Sorry. And you're taking that algebra that you learned, base times height, and you're putting it with the limit, and that's giving you integration. Okay? So I'm not going to go through this with you. What I suggest you do, maybe if you want to really get into it, get on YouTube and type in Riemann's theory and watch it. Okay? And you can watch it in the videos on the MyLab's math also, but I'm not going to go through Riemann because to me, I've already shown you how algebra and the limit theory work here. So this is what you should be saying to yourself. Well, that'll make me appreciate the integration because I ain't got to do all of this what? All of this work. Because you saw how much work you had to do here, and it made you appreciate the what? The calculus. Well, Riemann makes you appreciate the calculus with integration. Does everybody understand that? So I'm not going to send, but in a nutshell, I will show you what Riemann shows you. This is what Riemann shows you. Here's a curve. Okay? And you want to find the area under this curve. Well, we all know that we do it with rectangles. Everybody understands that, right? And each one of these rectangles has the same width. Let's say that Mr. Pangella, he don't want to do either. He don't want to do no calculus, and he don't want to do no Riemann theory. So he takes each one of these widths, and he calculates at let's say this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Okay, everybody see that? So each one of these rectangles is 2. And f of x is equal, I'm just going to make up something, negative 1/2 x squared. Okay, I just made up something. Well, what he's going to do, he's going to try to find out this height right here using this 0, let's see, plus 7. And he knows that this height right here is 7 because that's a y-intercept. Everybody with me? So he goes, okay, the area in this curve, the area right here is 7 times 2, which is what? 14. And then he goes right here and goes, well, that's about the same. So that's about 14. That's probably about 13. That's probably about 12. That's probably about 10. Everybody with me? And he does that all the way down 8, 6, 4, 2, 1, 1/2, 1/4. And he adds all those up and he gets some kind of area. That is the basic geometry way of doing this. Riemann says, instead of doing the width of this box, and write this down, Riemann says find the midpoint. And he says don't use the 2, use the 1. Okay? I mean, use the 2, but find the height at the midpoint. And find the height here, and find the height here, and find the height here, and find the height here. So the difference between Mr. Paniella doing it with the orange rectangles and Riemann is Riemann says find the height at the midpoint between this point and this point. Find the height between these 2 points. Find the height between these 2 points. Find the height between these 2 points. And go ahead and multiply by 2. And that's the difference between just doing it the geometrical way and with Riemann. And then with Riemann, you add all these up. Okay, that's the difference between the two. Okay, now let's go to integration. Now there's 2 words that I've used today about chapter 5. One is called antiderivative. And the other is called integration. They're used interchangeably. Some math teachers will say this is the process of finding the antiderivative. And some people say that the antiderivative is the actual term that you get or the solution that you get using integration. But just realize that they work hand in hand, okay? I'm not going to split hairs with you and say, oh, well, you have to use the word antiderivative here. No, you don't. Okay, there's 2 types of integration or antiderivatives. There is the definite and indefinite. Both of them have the S as a symbol. Definite has numbers right there. And then a function, x squared plus 3x dx. X to the third minus 2 dx. Now this is a very important part. Somebody tell me what is the area of a rectangle?
Length times height.
Base times what? Height. And what did I tell you the base of those rectangles were called? Okay, let me go back.
The midpoint.
Let me go back here. What did I tell you that the base, well, I had it shown somewhere. The base, what did I tell you the base of these rectangles were called?
Dx.
Dx. So where do you see dx here? That's your width of your rectangle. That's the width of your rectangle. So what's the height?
Function.
Your what? Your function. So the area of a rectangle is base times height. Base times height. Now it's important for you to see that. So I'm going to take my marker. That's the height. And this is the base. Base times height. Base times height. This is your x. These are your x's. So from 0 to 6, and we'll get to this later, that's your definite. Definite, you have parameters. Indefinite, you do not have parameters. This is more of like theory. Okay? So, these two are interchangeable. This is basically the process to get this. These are the two types of integrals, or the two types of integration. Definite, that has parameters, and indefinite, which is more like theory or academic. Trying to think of a good example. I can't think of one right now. But anyway, always look for that symbol. That symbol right there says I'm finding the area under a curve or a square or whatever the case may be. So, how do you find the antiderivative? Well, that's where you go to your handy-dandy handout. There you go. And there's your power rule right there. Exponential rule. We're going to get to all of these. And there's a substitution rule that doesn't show that. But we're going to focus on this one right here today. Now, here is f of x is equal to x squared. And that's what a function looks like. When they wanted you to find the derivative, they would do d dx of f of x. And then you would go over here and you would say, that would be 2x. Well, now in chapter 5, they won't give you all of this. They'll just say, find the antiderivative of x squared dx. Now, the actual integration is as follows. Here's the power rule. It's the opposite of what you did with derivatives. X squared plus 1 over 2 plus 1 plus c. Now, a lot of people at this point goes, okay, well, I understand that, but what's the plus c? Well, when you're talking about indefinite integrals, when you're talking about indefinite integration and you don't know what this x is or what is the, what you're doing, you're just guessing because it's academic. You have to put the c. Why? Well, I'm going to go up here and we're going to do a little experiment. F of x is equal to 2x minus 7. F of x is equal to 2x minus 1/2. F of x is equal to 2x plus 107. Everybody with me? So somebody tell me what f prime of x is right here.
2.
What's f prime of x here?
2.
What's f prime of x here?
2.
Well, I don't understand. You telling me that the derivative of all three of these is 2? But they're different equations. Yes, but they belong to the derivative is equal to 2 family. Okay, because this goes out with the derivative. So when you do the antiderivative, you have to compensate for that -7 and that -1/2 and that positive 107 by saying what? Plus c, because you don't know what that number is. You just know that you're getting the 2x when you're doing the antiderivative. Okay? So, is there teachers that's going to teach you Calc 2? Will they take off if you don't put C on the test? Yes, they will. They will count the answer wrong. So I'm going to go ahead and tell you, even for some of y'all people that don't believe me, if you don't put a C, especially with an indefinite integral, they will mark it wrong. Some teachers will mark it wrong. So this one is x cubed over 3, which is 1/3 x cubed plus c. And either one of these is your answer. Now that's your basic power rule. It's the opposite of the derivative. Instead of subtracting 1, you got to add 1, and then whatever you do here, you have to do the same thing right here. So let's take a yellow highlighter.
Priority 1 message coming in on secured channel.
And make sure you make that note. Well, what about all the other rules with derivatives? What about pulling a constant out? Yes, you can pull a constant out, just like derivatives. What about rewrites? Rewrite before you start. Yes. Always rewrite before you start, especially with radicals and with negative exponents or the exponent being in the denominator, bring it up. What about with sum and difference? Sum and difference, you do the same. If you've got 3 terms and you're adding and subtracting, you can do each one of them as far as antiderivative. So let's do one. Let's do a sum and difference. Antiderivative of x squared plus 2x minus 3, and I'm going to put an x to the 0 right here, so y'all will remember what to do, dx. So take the antiderivative of those three terms. Technically, you could break it up into x squared dx plus 2x dx plus, or minus, sorry, minus 3x to the 0 dx. And you can pull that 2 and that 3 out, x squared dx plus 2 antiderivative of x to the first dx minus 3 antiderivative of x to the 0 dx. So the same rules apply as far as doing them, separately, as far as pulling this 2 out front and 3 out front. You can still do that just like you did with derivatives. But now this is x cubed over 3 plus 2 times x squared over 2, because that's plus 1 over 1 plus 1, and that's plus 1 over 2 plus 1, and that's plus 1 over 0 plus 1, minus 3 times x to the first over 1, and that's x to the third over 3 plus x squared minus 3x plus c. Now, the good thing about this is that y'all have done so much work in derivatives, and you've done so much work with the power rule, you're going to remember how to do things when you do these because of your derivatives. Okay, well, that's 2 indefinite. Here's an indefinite. That's an indefinite. And that's an indefinite. Indefinite usually gets what? A C at the end. All right, well, let's do a definite. A definite integral would be one like this. The antiderivative of x squared from 0 to 9 dx. Okay, well, what do you do, Hubert? Well, you go ahead and do what you've been doing. X to the third, 2 plus 1 over 2 plus 1. And that's equal to x to the third over 3. And now we're going to evaluate that from 0 to 9. What? Evaluate? Yeah, because you've got a function that looks like this. I'm exaggerating it a little bit. There's your f of x is equal to x squared. And they want the area under the curve from 0 to 9. So there is what you're trying to find. And that's where the 0 to 9 comes in. Now, the 9 is always the one you subtract from. The 0 is the one that's being subtracted. You got to plug and chug. This symbol right here means subtraction. That symbol right there means subtraction. So we're going to go to the next page, and we're going to do this part right here. So I'm going to rewrite x to the third over 3, evaluated from 0 to 9. So I'm going to write my problem with a big set of parentheses, because that's not beneath me. Subtraction, big set of parentheses. And I'm going to take a highlighter. Nine is the number that you always subtract from. And 0 is what you subtract out of, or you subtract. So 0 would be, I don't have, there we go. Now, what's the good thing about 0? Somebody that's had pre-calculus or calculus before, what's the great thing about 0?
It's both positive and negative.
Well, it always what? What
Neutral.
does 0 always do?
Makes everything 0.
What does it do here?
The answer is 0 because you can't do nothing.
It cancels out the term, right? Since algebra, doesn't 0 cancel out everything? Yes, Hubert, that's right. So it just cancels that out. So now all you have to do is this math right here. 9 to the third over 1. Well, 9 to the third is 9 times 9 times 9 over 3. Technically, you could cancel out one of these, but I'm just going to do it. 9 times 9 is 81, and 81 times 9 is 729, isn't it? Somebody check my math.
That's right.
And 3 will go into 7 one time, or 2 times. 4 and 3, somebody check my math. So your area under this curve is 243 square what? Square units. Somebody check my math though, make sure I did it right.
You were right.
Now, that's all there is to the antiderivative. Now, there's some more complicated problems like with natural log and exponents, and we'll get to that. But that's as simple as you can get. And I will tell you, there are some calculus teachers that make this difficult. I hope I didn't, but there are some. All right, you ready for be on your own? Let's do one on your own. It's going to be kind of like this one. I want you to find the antiderivative from 0 to 4 of 2x squared plus 3x minus 2 dx. All right, go to it. I also want you to graph it on your calculator and transfer that to a sketch And I want you to go from 0 to 4, and I want you to fill in where you think you're finding the area. I'm going to go ahead and type in the calculator since it takes me a little bit with this mouse. Okay, what's the problem on this one? The problem on this one is that part of your area is where?
Below 0.
Below 0. It's negative. And above is positive. Now, you can't have a negative area. So what does the negative mean? It means the area is below the x-axis. So you have to break this one up into two sections. From 0 to 1/2, and from 1/2 to 4. So you've got to set this problem up into two. Now the antiderivative or the integration, that doesn't change. It just basically busted up into two problems. Okay? So, or you could do it all together and it will give you the same number, but there are some applications and there are some questions that will ask you for these two areas separately. So I'm just going to show you how to do it from the get-go. And we know we can do the antiderivative right here. So this is going to be 2x to the 2 plus 1 over 2 plus 1 plus 3x to the 1 plus 1 over 1 plus 1 minus 2x to the 0 plus 1 over 0 plus 1. So our antiderivative is going to be 2x to the third over 3 2x to the third over 3 plus 3x squared over 2 minus 2x over 1, which is 2x. This is your antiderivative, or your integral. Now we're going to use that to go from 0 to 0.5 and from 1/2 to 4. We're going to use this evaluated from 0 to 0.5 or 1/2 and from 1/2 to 4. So we got two problems to set up. So the first one is 2/3 x cubed plus 3/2 x squared minus 2x evaluated from 0 to 1/2. The reason I'm not using 0.5 is because I'd have to use a calculator to do that, and I'm not going to use a calculator, and you shouldn't either. Plus, and this is under the x-axis. I'm going to put under the x-axis because I don't like to put a negative with with area because it doesn't make sense. So I put under the x-axis. And then the same thing, 2/3 x cubed plus 3/2 x squared minus 2x from 1/2 to 4. And there is your. Now, what's the good thing about 0?
It cancels
Cancel.
out.
It cancels out
0
everything.
cancels everything out. So you don't have to do 0 here, just 1/2. So 2/3 times a big set of parentheses, because they're not beneath me to use parentheses, plus 3/2 squared minus 2 times parentheses. And I'm going to plug in that 1/2 right here, right there, and right there. And since the 0 takes out all of that, I don't have to subtract that. Plus brackets. I've got two things to do over here. So 2/3 times parentheses cubed plus 3/2 times parentheses squared minus 2 times parentheses minus 2, I'm going to put this in parentheses, 2/3 parentheses cubed plus 3/2 parentheses squared minus 2 times parentheses. And I'm going to plug in a 4 here, a 4 here, and a 1/2 here, and then a 1/2 here, and 1/2 there. Now, it's not that difficult because 1/3 is 1/8. 1/2 to the third, that's 1/8. So 2/3 times 1/8 plus 3/2 times 1/4 minus 1 plus brackets. And I'm going to make this, hold on a second. There we go. And I'm going to put parentheses, I'm at this bracket right here. And this bracket right here. There. Okay, so this is going to be 4 to the third power. 4 times 4 is 16. That's going to be 64. So that's going to be 2/3 times 64 plus 3/2 times 16 minus 8 minus 2/3 times 1/8 plus 3/2 times 1/4 minus 1. And now it's just a matter of mathematics. What does the 2 and the 8 do right here? Cancel Hubert, and that makes 4. So that's going to be 1/12. Somebody check me on that. Plus 3/8 minus 1. Plus, and I'm going to put a big set of brackets here. And that is my red brackets. And 64, that's 128/3. Two will go into 16. 8 times 3 is 24. Two over 24, which is 1/12. 3/8 minus 1. And now it looks like we just got to get a common denominator. It looks like 12 and 8 is a common denominator with everything. So I'm just going to go ahead and get a common denominator with everything. Make life a whole lot easier on me. So 12 and 8. 8 and 12. 2, 3, 5, 7, 11, and sometimes 13. 2 will go into 8 4 times. 6, 2, 2, 3, 2, 1, 3, 3, 1, 1. So 6 times 3 is 18. Is that right? 2 times 2, what is it? 2 times 2 times
Yeah, that's
2 is 8. 24. Right? 6 times 4 is 24, so 24 is our common denominator. So I'm going to put a 24 here, 24 here, and a 24 there. And 12 will go in there, that'd be a 2. 8 will go in there 3 times, 9, and 24. Plus parentheses are brackets. And that'll be a 24 here, 24 here, 24 here, minus 24 here, 24 here, 24 here. 3 will go into 24, 8. 8 times 1, 28. Well, that'd be a 4. 8 times 2, 16. 2. I done messed up. Somebody multiply 8 times 128 for me. 8 times 128.
1,024.
I'm sorry, what?
1,024.
1,024. 1 will go into 24, 24 times 24 is what? What's 24 times
576.
24? What?
576.
I'm sorry, what?
576.
Thank you. The reason I have to say what is, I don't know if it's y'all's microphone, but y'all's first letter or first number, I can hardly hear it, and then it comes in clear. 12 will go into 24. 2 times 1 is 2. 8 will go into 24. 3 times 3 is 9. 1 will go into 24. And now let's get it down to bare bones.
You skipped the one after 576.
Okay, 1 will go into 24. 24 times 8 is what? 216? Somebody help me out, or 212. What is it?
192.
192.
I suck. 192?
Yep.
All right, so 2 plus 9 is 11. And 11 minus 24 is negative 13. Somebody check my math.
Oh.
11 minus 24. Did somebody check it?
Yeah, you're right.
Okay, thank you. Notice, is it positive or negative?
Negative.
That area, 13 over 24, is below the x-axis. Plus, well, 1,024 plus 576 is 15 or 16. 1600. Somebody help me out. What's 1,024 plus 576?
1,600.
Minus 192.
1,408.
2 plus 9 is 11. 11 minus 24 again is negative 13 over 24. And negative 13 over 24 plus, that'd be 1421. Somebody check my math. And somebody give me negative 13 plus 1421. What do you get?
1,408.
And divide that and give me a mixed number. Or give me decimal. What is it? 1408 divided by 24.
58.6 repeating.
58.7
Yeah.
square what? Units.
Units squared. Or square units.
So this area right here is negative. Somebody give me a decimal of 13 over 24, please.
Zero point 5416.
0.5 what?
0.5416.
Okay, I could not understand after you said 5. I'm sorry.
5,4.
546?
16.
5416. Thank you. 5416 square units under the x-axis. And then this, somebody take 1421 and divide by 24, please. Give me a decimal.
59.208.
59.208
Mm-hmm.
square units. And of course, it's positive, so it's above the x-axis. And you add those two together, because that's negative. That means 58.7. Now, I know that was a little bit tedious, okay, but the reason I'm showing you this one is that's the kind of question I would give you on a test. Now, so in some ways, they ask you to set up, and they don't ask you to do the math. So they may ask you to do that too. I don't want you working on any homework tonight, okay? One is I haven't looked at it yet, so don't do any of it yet because I might take some out. All right? The rest of you, if you're one of the 8 to 12 students that took the test and are satisfied, you have the night off, okay? If you're not, then you need to finish that test tonight. Let me check the roll right quick and turn off everything. And